Hello guys, yeah, welcome back to my YouTube channel. I am Adipo Jamdi Samuel, popularly known as Dr. Sammy. So if you are new to this channel, please kindly like this video, share and comment. Share your thoughts concerning this particular video. If you love it, drop it. If there's any part that is confusing that you're not clear about, that you are still having doubts that I did not understand this part, drop that part so that we can retrace it. So I just want you to know that in this channel we are lovers, and then your voice counts. So on today's topic, I'll be treating a particular course for 100 level students in second semester. So this for physics 100 level students in second semester. So the course code is PHY 102, and the course title, what I'll be treating and teaching you today, is electrostatics. That's one part. Conservation law of electric charge. That's another part. So we're treating these two parts in details. I will break this to the barest and lowest units possible so that everybody could what benefit from this video. So first part is electrostatic. Now, what is electrostatic? Electrostatic is just a phenomenon whereby electron or electric current does not flow in the material. So electrostatics is a phenomenon whereby electric current does not flow in a material, or charge does not flow in a material. So that's what we call electrostatics. So what do I mean by this? Now, have you noticed something in real life situation or real life issue, that if you carry a metal, and then have you noticed that if you touch that metal, it will not shock you? Do you know why it did not shock you? It is because the metal is in electrostatic state. The charge are at rest. The charge are at what? Are at rest. So the charge is not moving. So that is why you are not shocked by it. And this kind of state is what we call electrostatic. Is when charges does not flow in a material. So I've given you an example. If you see iron and you touch the iron and it did not shock you, you should know that the iron is in a state of rest. And that state of rest, that is the charged particle are at state of rest. And that state of rest is what we call what? Electrostatics. So those period that the iron will shock you is when current is flowing through the metal, current is flowing through the iron. So you go see say light fall on that metal, so current is flowing through the iron. That's when it will shock you. But when the particle is at rest, no current flowing at it through the particle or the material, then that kind of state is called electrostatic state. So thereby the definition is electrostatic is a situation where charge does not flow in a material. So as simple as that. And I've used conductor. The metal is the conductor. I've used it as example that this your metal iron. If you touch it, you see that sometimes it will not shock you. It is because the charged particles in that iron are not flowing. So you get what I'm saying? Are not flowing. That's why they not shock you. And this state is what we call electrostatic. Now, for the other example, I can use this insulator. You will see that those material like your marker, all those material that does not use to shock you, is because their particle are at what? Are at rest. Those kind of material do not use to allow um their charge to flow, do not use to allow current or charges to flow through them. So those particular material the charge particle are at rest. So that is why they did not shock you. So this state in which this marker that I'm holding did not shock me, because, and it can't shock me because they do not use to allow charged particle to flow through them, and the charged particles that are contained in this marker are at what? Are at rest. This state is what we call electrostatics. So when you see your comb, you should know that it's an electrostatic material, because the charged particle is at what? Is at rest. As simple as that. So now the next part I'll be treating with you is electric charge and the structure of the matter. So now I've been talking about charged particle, charged particle, charged particle. This is what I've been talking about charged particle is that every material is made up of what? Atom. So atom is like a particle that forms every material. That is, in every material, there's a presence of atom in every material. And this atom that I'm talking about is formed by three particles. It is formed or it consists of three particles, which is proton, neutron, and electron. So atom is made up of three particles, which is proton, neutron, and electron. So I use this diagram to illustrate it for you. So any material always consists of atom. An atom is made up of what? Proton, neutron, and electron. So now this is how it goes. This outer shell, this is what we call outer shell, is an electron orbital. So it is electron that used to stay at this shell, while this inside is proton and neutron. While the shell that is covering this inside part is what we call nucleus. So inside your nucleus, you find your proton and your neutron. And this outside shell is what we call electron orbital. So now let's move down to proton. Proton is positively charged. So these are proton is positively charged. Proton is positively charged. The neutron is neutral, and the electron is what? Negatively charged. So this means that electron is negatively charged, proton is um positively charged, and neutron is neutral. So in your nucleus, you can find proton and neutron. That is, the nucleus will be positively charged because this our neutron has no charge, it is neutral. So do you understand that? Okay. So and the mass of electron is this 9.109 times 10 raised power minus at 1 kg. Mass of neutron, this is the mass of neutron, and this is the mass of proton, 1.673 times 10 raised power minus 27 kg. So which is kilogram. So hello guys. So the summary of what I taught you last is what we did electrostatic in the first part. This is the second part, electric charge. So for the first part, which is electrostatic, what electrostatic is that is a situation when charge does not flow through a material. When charge does not flow in material, when the charges in the material is at rest, that's what we mean by electrostatic. And I gave you some sweet illustration, which was metal will not shock you because charge does not flow in it. So therefore, the charge is at what? At rest, is not flowing. So since it's at rest, therefore the material is at an electrostatic state. So that is why electrostatic definition is that it is when what? That does not flow through a material. I gave you that every material is formed by a building block. Which material is I told you that every material is formed by what? A building block called atom. Atom. So and I explained atom to you that is formed by what? Three subatomic particles. So or see three particles. So atom has three particles that forms it too. So which is proton, electron, neutron, popularly called pen. So I just want to quickly revise it, and I gave you a diagram which is atomic shell. So I told you that proton is inside the nucleus. I showed you what nucleus is, and and the the neutron too, and I showed you the electron shell. Electron is at the outermost shell. So and I gave you the mass of each, which is proton, electron, and neutron. Ensure you watch the video, understand it, so you'll be able to understand this part too. So, but do, on this particular part, the second part, we'll be treating electric charge conservation. So now, this part we say that charge of an atom is determined by the what? Subatomic particle that made it up. So I told you last part that the particle that made an atom up is proton, neutron, and electron. So now let me show you something. This is the nucleus. So nucleus. This is the proton, and also electron is neutron is here. Neutron. So and the outermost shell electron. This is negatively charged, positively charged. Neutron has no charge. So that's all. So nucleus is the shell that cover these two, which is proton and neutron, while the outermost big shell is contained by electron. So that is just it. Now I told you the reason why electron is covering this nucleus, the reason why electron is revolving is to neutralize this positive charge. That is why is to neutralize this positive charge. That is why all atoms are neutral. All material you touch is neutral. So that is why they will not shock you unless something happen to it. It will not shock you. So for instance, let's say there's three electron in this place, there will definitely be what? Three proton. Why? Because this electron, the aim is to what? Neutralize this proton. So that is plus 3 minus 3 will be 0. Electron, proton is positively charged plus 3. Electron is negatively charged. If you do the summation, you see that is equals to 0. That is, every atom is what? Neutral. Every atom in natural state, it is what? Neutral. So, but there's something that used to happen. This proton now is held together. This proton and the neutron that is in the nucleus is held together by a very strong bond which we call nuclear force. So that's the force that hold it together. So this proton cannot be transferred, but this electron can be transferred. So this electron what can be transferred. So that is, you can lose one electron, you can gain another electron. That is why we say that the charge of an atom is determined by the subatomic particle. So the charge is determined by a particular phenomenon, which is if the proton or if the electron lose one of its value of or if an electron is being what gained. So let's do an instance. I just want us to practice something. Let's say that one electron is being gained. That is, we have what? How many electrons now? One, two, three, four. So that so we have how many electrons now? Minus 4. And then let's just say one electron is being gained. Now let's calculate it. So minus 4 plus how many protons do we have? Plus 3. And we have 3 protons. Can you see that it is now charged? It is what? Negatively charged. Why? It is because if you solve it, electron is negative minus 1, 1, 2, 3, 4. Proton 3 positively plus 3. If you do everything, you see that this is why. If you see that it is negatively charged. Why is it negatively charged? Because it has gained one electron. So now let's check another scenario. Let's check the part whereby it lose 2 electrons. Let's say it lose 2 electrons. 1, 2. What will happen? You see, the atom will not be neutral again to carry charge. 2 electron, which is 2 electron and 3 proton. Minus 2 plus 3. Can you see now? To be positively charged plus 1. So what the summary I will give you now is that charge particle of an atom is determined by the subatomic particle. So if an atom will be charged, it is determined by the subatomic particle. What does this actually? So when an atom is charged, what it means is that at least an electron is being lost or gained. So that's just it. So the particle that determines if it is lost or gained is electron. So an electron is subatomic particle. So that's where this statement is coming from, that charge of an atom is determined by the subatomic particle. So it's determined if electron is lost or gained. So that's what we determine the charge that an atom will carry. So, but normal state, atom is always what? Neutral. So let's just say the normal state, if there's 3 electrons, there must be 3 proton here. So it will be what? Neutral, it will be 0. But if this electron is lost or if it is gained, therefore it will be what? It will be charged. So that is, the charge of an atom is determined by the subatomic particle. And these are the subatomic particle: the proton, the electron, and the subatomic particle. The neutron is neutral, so it has no business with that. So now, conservation law of charge. So this one also is still pointing back to this, that charge cannot be created nor destroyed, but it can only be transferred. Can you see now? You cannot destroy electron, you cannot destroy proton. What is happening here is only what? Transfer. And the only particle that can be transferred is what? Electron, because it's at the outermost shell, so it's easy to transfer, it's easy to gain. You get what I'm saying? So but the inside one cannot be transferred, which is the what? Proton. So do you understand that? So as easy as that. So I gave you a scenario that An atom is neutral because proton and electron is what? Is equal. We have said it here. Proton, electron is equal, atom is what? Neutral. We said sodium. No, now the atomic number of sodium is 11. That is, if you look at the periodic table, the number where you find sodium is 11, while for hydrogen is 1. For nitrogen, the number you find nitrogen, if you count other elements before you miss nitrogen, nitrogen is the 7th position. So, and that position is what we call atomic number. So that is, if you are looking for sodium in the periodic table, you count the number 11. So 11 is the atomic number, and the atomic number is still same value with proton and electron of an atom. So therefore, that is why I wrote 7. Sodium atomic number is 11. So let me represent it in this here. So if the atomic number, that the proton and electron, so will be 11. So let's do 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm just doing it as rough scenario so that you understand what I'm saying. So let's do for the proton to 11. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now that is, we have plus 11 minus 11. So it will be what? Neutral, 0. So all atom, it is normal, in its normal state is always what? Neutral. So take note of that. And now charge. All these electron, proton, they are charged. They are positively charged and negatively charged. So they are charged particles. So charged particle in physics is denoted by this value or this letter Q. And then the magnitude, the value of this charge is 1.60 times 10 to the power minus 9. What I mean by this is that for proton, so one proton, which is same thing as plus q, because I've told you that proton is positively charged, electron is negatively charged. So for one proton now, the value, that is the value, the quantity you want to quantize it, the value it carries is, for one proton is 1.60 times 10 raised power minus 19 coulomb. So if you want to say for two proton, that is, it will be twice of this value. For three proton, the value it carries, that is the magnitude, is 3 of this value. Same thing for electron too. So one electron is also 1.60 times 10 raised power minus 19 coulomb. So for two electrons, it will be twice of this value. For three electrons, it will be thrice of this value. This is theory that I'm trying to write. So it's as simple as that. Example. For the first example, an object has a net charge. You can carry your pen and Bible, jot this out. An object has a net charge 8.0 times 10 to the power minus 19. This is coulomb. So it's a unit for charge under physics. An object has a net charge 8.0 times 10 to the power minus 19 coulomb. So has a net charge of, how many net charge of multiple E is present in the charge? So that's the question. I made mistake writing. How many net charge of multiple E is present in the net charge? So let's take the question again. An object has a net charge of 8.0 times 10 to the power minus 19 coulomb. How many net charge of multiple E is present in the net charge of the object? So how many net charge of multiple E is present in the object? Let me just put it in the object. So this is very, very simple. So the object has a net charge of 8.0 times E. So the net charge of the object is what? Net charge of the object Q is what? 8.0 times 10 is power minus 19 net. So the net charge of the object is this. Mind you, should write solution. So the net charge is Q, which is this. So how many multiple of electron is present in this charge? So we want to look for how many electron is in this charge. Electron, we did not know. So now, and I told you that one electron has a value. So you get, it has a magnitude, and one electron is, I told you before that one electron is 1.60 times 10 raised power minus 19 coulomb. So to get how many electron that is present in this net charge, It is very 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 simple. So it will look like this. To get how many electron are expelled, that is, we will use what we have to do is to find how many of this electron is in this. It is simple. So what you do is that this is the total net charge. This one 0 times 10 power minus 19 coulomb. You will what? You will divide it by the what? By the value of what? Electron, the magnitude of one electron. So you divide the total by the magnitude of one electron, so that we should know how many of this that is in this. So we want to find the multiples of E in this. So it is very simple. So divided by 1.60 times 10 raised power minus 19 coulomb. This can cancel this out. So, or you can simply put 8.0 times 10 to the power minus 19, divide it and press 1.60 times 10 to the power minus 19 in your calculator, it will give you answer. So the answer is what? 5. So that is, in this net charge value, you can find what? The multiples of electron you can find is what? 5 electron. So as simple as that, it is not hard. So it is not hard, as simple as that. And if you want to check what is the value of this 5 electron, that is the magnitude, the value of charge of this 5 electron, it is simple too. You multiply 5 times 1.60 times 10 to the power minus 19 coulomb, and you get this, the value back. Shey you get? So but to get how many electron that is in this net charge, it is very simple. You should know the value of one electron in this. So if value of one electron is this, how many of this one electron can you see in this total charge? How many value of this one electron can you see in this total charge value? That's what they're asking you. So you just have to divide the two, so you know how many of this you can see in this. And it is what? 5 electrons. So as simple as that. So there is still one thing I want to let you know is that, like, note, like charge, like charge repel, while unlike charge attract. So this is a common law of charge. Unlike charge attract. So note, like charge with what? We do what? We repel. Boy and boy will not date each other, but opposite sex will what? We date each other. So that's just how it is. I'm not talking about European culture where there is gay and lesbianism. I'm talking about Africa. So this is why this is same law of charge. Like charge repel, while unlike charge attracts. So as simple as that. I've solved this question for you, and it's as simple as it is. So I'll drop a poll question like this. So just be expecting a poll question like this. You can practice that. Easy. For Coulomb's law of charge states that force between two point charge is directly proportional to the product of the charges and inversely proportional to the square of the what? Of the distance. So that's the law of what? Coulomb. That the force between two charge at a distance is directly proportional to the product of the two charge and inversely proportional to the square of the distance. So by formula, what this means is that F equals to K is constant. K, the product of two charge, which is Q and Q, to multiply each other. Inversely proportional, as is all over the square of the distance, which is r square. So this our r represents distance. This K is a constant. This F, okay, let's just say F is force. Let me write it down. And the unit is Newton. The arrow is distance, so they denote distance, and the unit is in meters. The Q is charge, so first charge and second charge. So and the unit is coulomb, and K is constant, and it has its own value. This is the value of K, 8.988 times 10 raised to the power 9. The unit is Newton meter square. This line is per coulomb square. So that's what the parameter stands for. So this Coulomb's law, what it means is that there is force. Okay, let me show you the distance. When 2 point charge plus, let's just say this Q, first charge, they are at distance to each other. This negative charge Q. So I told you that Like charge what? Attract. No, like charge repel each other and unlike charge what? Attract. So if you look at this charge, this Q1 is positively charged. The second Q2 is what? Negatively charged. So they are what? Opposite charge. So what will they do? They will attract each other. So there will be force between this charge because they are attracting each other. You can't attract something without pulling it or without a force into that scenario where you want to attract something. So therefore there's a play in this there's a play of force in between these two charges. So how do they exert force on each other? So this Q1 now, we try to pull this. Okay, let me give you another scenario. A positively charged particle, this is what a positively charged particle always what? They always flow outwardly. So positively charged particle always flow outwardly, and negatively charged particle always flow inwardly. So take note of this, always flow inwardly. So now what this means is that this is for positively charged particle P and negatively charged particle. Let me just write E, electron. So now for this positively charged particle now, shey you get what I'm saying? Uh it is trying it will try to what? Pull this one here. Shey you get? It will try to what? Pull, pull. So they will try to attract each other. This one will try to attract this because they are what? Opposite charge. So the force is it is going to use to this first particle here now we try to the force it will use to that is um force of first charge particle on second charge particle shey you get to try to pull this one. So it is F21 and this is trying this charge will try to pull this one like this. So they will attract each other. So this is attract. So they want to come together. So this will pull this one like this, which is what F12. Simple as that. This is first charge first charge particle trying to pull second charge particle F21 and which is this is the first direction. For the second charge particle 2 trying to pull this first charge particle which is 1. So to try to pull each other. So and this distance between their two is R. So for same charge particle, this is Q2, Q1, they are going to repel each other. They are going to repel each other. This one will push this one, this one will push this one. This one attract this one, and this one attract this one. So this is the force. This one is using to attract this one. This one is the force. This is the force. This is using to attract this. So that's what I denote here. And this one will push this one. This one will push this one. So to be when this one push this one, the force will move like this. So let me write it very well. To move like this. When this one push this one to move like this. So Q1 will push Q2. So it will be something like Q1 pushing Q2. So Q1 pushing Q2. So this Q2 will push Q1. It will be something like F1, 2. So Q2 pushing Q1. So that's just it. So like charge repel, which is this, they are like charge at the same charge, but different charge attract, which is this, and this is their force of attraction. This are force of repulsion. So and to calculate this force, this is the formula. But as simple as that. So like charge what? Repel, unlike charge attract. And Coulomb's first law state that if you want to get the force that is repelling or the force that is attracting, the formula it is the product of the two charge divided by the square of the distance. So I'm just illustrating here on how they what attract each other and how they would pull each other away, which is repulse themselves and how they would attract themselves. So it is as simple as that. So that's just the illustration. Q1 push, Q1 attract Q2 because it is different charges, and Q2 attract Q1, so they will attract each other. Now here, because the same charges, Q1 push Q2, this is the force it is using to push Q2. Q2 push Q1, this is the force it is using to push Q1 in this direction, so they repel. So that's just it. That's Coulomb's law illustration. So to calculate the force of attraction or repulsion, this is now the formula. As simple as that. I see another scenario. This is the calculation under Coulomb's law. So the question goes like this. The electron and proton of a hydrogen atom are separated by a distance of 5.3 times 10 to the minus 11 meters. So R, the distance 5.3 times 10 to the minus 11 meter. And they are saying that the electron and proton, so um, of an hydrogen atom are separated by a distance of this. Calculate the attractive force. So they want us to calculate F. So we need to know our Q1 and Q2. Q1, that is the Q1 will be the charge of electron. I remember I told charge of electron, the value is 1.6 times 10 per watt minus 19 coulomb. And Q2 will be the charge of proton, abi, which is also something at 1.6 times 10 per minus 19 coulomb. Remember, this electron negative positive. So you get, so they say that's charge for electron, charge for proton. So now the formula for force, we know our K to be 8.988 times 10 raised power what? Times power 9 Newton meter square per coulomb square. So our formula will be, remember Coulomb's formula to calculate force, Q1 Q2 over R square. As simple as this. So it is attractive force because positive and negative will attract each other. So that is why it is attractive force. So therefore, K is what? 8.988 times 10 raised power 9 times. Now multiply the two, 1.6 times 10 raised power minus 19 times another 1.6 times 10 raised power minus 19. So we are following this formula. This is K, this is Q1, multiply another Q2. So as simple as that, and R square, which is 5.3 times 10 raised power minus 11 square. So as simple as that. So now if you punch this in your calculator and divide it by the square of this value in your calculator, your final answer will be 8.2 times 10 raised power minus 8 Newton. So this is the force of what? Attraction. So as simple as this. Thank you.